Right here. Wasn't even an accident on my side of the freeway, but if there's an accident on the other side of the freeway, everyone wants to slow down, like 3 miles worth of slowness because we wanted to drive past some fire trucks and ambulances and things. Like, I don't understand why people can't drive, but that's okay. So I, for one, am looking forward to self-driving cars. I think we will do a much better job of that. But how long is it going to take to get all the current cars off the road? It's just going to be a while. It'll be a while, but I think we'll get there. I'm pretty excited for it. So first thing, I did fix our Sudoku solver. I was very excited. And this is one of the cool things about GitHub here, is you can see what changed when. So you can take a look at all the commits here. So this was when it was almost working here. Then I needed to count the row we were on when we were doing our count function here. I was looking for a 0 of the 2-dimensional board, and what you have in the first dimension is another set of vectors. So I was never going to find a 0, and that's what that error was telling me I can't find an integer in a bunch of vectors. But if I grab the row that we're at, then I can look for zeros inside that row, and that fixed that problem. And then I had one more. Our arithmetic here was messed up because my for loops here, when I had done starting at times 3, bless you, I didn't change the less than check, so it wasn't checking far enough. So the simple quick fix was to just divide by 3 and multiply by 3. Right? Get your integer division, then multiply by 3. So I had 0, 3, or 6. So the combination of those two things fixed the Sudoku solver, and now we can solve a Sudoku puzzle, which my wife tells me is cheating, and I can't do this for my Sudoku puzzles. But I was like, I wrote it. Doesn't that count? And apparently it doesn't. So that, I guess we can debate that later. So where our source file is, we had this board, right? We took from Wikipedia's example or wherever it was, and we just Googled a Sudoku puzzle. And now when we run it, we should get out a solution here. And I'm pretty sure I checked the solution. Yep, so this was the original board, right, with all the zeros representing the blank spaces. And here is the solved board. So each row should have 1 to 9. Each row should have 1 to 9, 1 to 9, 1 to 9. Each column should have 1 to 9. Those don't highlight as well. And then each grid, right, this 3 by 3 grid here to here, that's a little small to see, but that should have the 1 to 9s as well. I think we are solved. So this particular form of recursion here has a name, and we're doing backtracking. This idea that we're going to try something, and then we're going to recurse. If it doesn't work, we're going to undo. Right? Take a step back, undo the thing we did, and then just try the next possibility. Okay, so backtracking recursion is not always the most efficient. I mean, probably most of the time it's not the most efficient way you can solve a problem. But it's a very conceptually easy way for us to solve a problem because it just literally tries every single possibility. Right? We just try and put a number down, try and put the next number down, try and put the next number down. There's no smart approach going on here. It's just brute forcing. Let's try until we find a solution, and then we'll get there because I think any Sudoku puzzles are going to be solvable. Right? If someone gives you a puzzle that's not solvable, then I don't know. I mean, they would have to give you one that was already in an invalid form or something. Maybe there's a way to make one that can't be solved, but I don't know that much about Sudoku. I'm assuming anyone we find online can be solvable because why would they not give you one that's solvable? This is a backtracking recursive solution. So there's a lot of different things we can solve with backtracking. And that's actually what our next project is going to be, is on using backtracking recursion. So we'll take a look at this one. We'll do one in lab today, which you're stuck with me, Mr. Diaz, out having fun at the conference, which is super cool. It's a real cool conference they're putting on over at OU for ASE. What is it again? I forget. The conference. Is that it? Oh, this will be the right hit. Yeah, what is this here? International Conference for Automated Software Engineering. This is pretty cool stuff that they're doing. So they've got a website and so on. So Dr. Casentini used to teach here, and then he moved over to OU, and now he's the department chair there. So he's a real nice guy. Really smart too. Really smart. All right, so that was our backtracking recursion. So other things we can do with backtracking recursion, right? Anytime we have a problem to solve that taking us one step closer to a base case, to a solution, right? That's one of the things we need to be able to identify to see if we can solve this with recursion. Can we take a problem that's not solved and get it closer to being solved? Sure, like our Sudoku. Not solved, one step closer is let's put a number in. Now we're one step closer to a solution, right? Now, the two things that can happen, though, are that we could solve the puzzle, right? Or we can't place something, right? If we can't place the value, that's a base case, right? No further work can happen. We can't get closer to a solution. That's our base case, right? It's not solvable based on what we've done. So we just try the next number, try the next number, try the next number, right? Going on through. So if we can put the value in, let's do it. Keep on solving. See if we get to a solution, right? This, I don't know why that's a question. Like, do we need to undo? So if we're not solved, right, this will undo this attempt here, right? So another fun thing, and I think we'll probably look at this one in lab, is solving a maze. If you have a maze, right, there's a couple ways you can solve that maze. The naive backtracking approach is try going a direction. If you get stuck, go on back till you can try something else, right? Just like we did here. You walk, if you come up to a left fork and a right fork, let's try the right one. If that doesn't lead me to a solution, come on back and try the left one. All right, I get to another fork. Okay, let's try the right fork. If that doesn't lead me to a solution, come on back and try the left one. Try the right fork, try the right one. As many as we need to do, we can attempt as many as we need to, essentially, to go through. Hector, my friend, thanks for donating those bits to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science. I've not had any coffee yet this morning, but I'm on Coke because I had this and could get out the door and not be even more late. It was a rough night last night. But. So the downside to these backtracking solutions is, remember, we ran out of space when we were trying one of these before. When we ran out of, and we had that Stack Overflow error. I said, hey, look, there's a website named Stack Overflow. You might have heard of it. So large problems that have lots of different possibilities are not going to be very good for solving with backtracking, because it will literally just try every single one and you can get stuck. So there's a classic puzzle here called the Night Tour. And I forget who came up with this one, but the idea is for any given position on a chessboard, you can put a knight down. Knights move in an L shape, 2 and then 1, and there's a path that that knight can take to land on all 64 squares with no repeats. For any given starting point, you can solve this. Now, if you just think for a second about how many different possible ways we could approach this, right? Okay, let me try the very first jump. Sure. All right, I'm going to take a jump. All right, let me try the jump again. Let me try the jump again. Like, eventually you won't be able to jump that same direction. But the number of possibilities here means you can't solve this easily with backtracking until you add an additional step. There's one extra thing you can do to make it quickly solvable with backtracking. But if you don't do that, your program runs a really, really, really long time. This idea here that for any given position on the board here, I don't know how small that is. Can you see that? Is that better? There are this number of jumps it can do. Right? So on these inner squares, there's 8 locations it can move each time. The outer ones have a little less, the corners have even less, because that's just where the knight can go here. So it ends up being a very large number of possible jumps that someone can do with this. Yeah, number of directed tours. That's millions, that's billions, that's trillions, that's quadrillions, right? So On an 8x8 board, there's 19 quadrillion distinct directed paths. We're not going to solve that quick. I mean, our computers are fast, but not that fast, right? So just trying something is not going to work out well, and that is one of the downsides of this backtracking recursion. What you can do is you can use Warnsdorf's rule. It's cool. It would be fun someday to have a rule named after me, but I'm not that smart. Um, just would be fun. So what you can do is, if you move to the square that has the fewest next moves, you'll be able to find a solution faster. So what that means is you want to prioritize the lower numbers here. So if I'm, say, at this position where there's 8 different moves, don't jump to another 8, right? Jump to a 6 or a 4 or a 3 or a 3 or like take the lowest one. So for your next jump, go to the lowest possible number. If you do that, it actually gets solved like that, which is crazy. This guy, I don't know how he came up with this, but it works. Super cool. Turns out your third move ends up on an 8 and going to another 8 and then going to another 8. If you do this the bad way, and then you're at like 3 billion wrong approaches before you ever come back to that third move never had a solution. So, doing this, we can actually solve it. So if we wanted to, it's okay. We probably don't need to do this. One's a little trickier to do, to add in this rule for the Warnsdorf rule that takes into account other positions we've jumped to and that sort of thing. But later on, when you talk about graph theory and all sorts of things, like you can apply that sort of rule as well. But it's interesting. You can solve it on a 24 by 24 board. Sure, why not? So it's got some fun stuff. So this is one where backtracking, it can work if you know the right trick here. Otherwise, we're just doing way too many things and we're going to get stuck forever. So similar idea with mazes, right? If we just have a giant open maze and we've got 100,000 different paths we could take, it's going to take a while, right? But a small enough maze, a decently sized one here, it won't be too hard for us to do some backtracking recursion. Because if you figure like a 20 by 20 maze is only 400 spaces here, right? How many unique ways are we going to be able to go around that? Is not that many here. Won't be too bad because you don't get to do jumping like the knights do. Like knights get to jump all over the place. So with the maze, you just have to kind of follow the walls. Is all. Hey, happy Blur's Day, White Paladin. Thanks for dropping on by. Have fun at your project review. So we can tackle a basic maze solver. Now, solving mazes is something people love to do, apparently. It's an easy-ish problem to tackle, and there's lots of cool different approaches. And if you continue on and take, I think they probably still teach it this way, the Intro to AI class does a lot of maze solving with different approaches to kind of look at some of these, what AI systems sort of do. It's one example, a sort of thing. So if you just Google like C++ maze solver, you're going to get all sorts of maze solvers, right? All sorts of different ways. We don't want to just go Google one, right? The idea is we're going to practice a recursive solution that does backtracking so that when your project, you have to do some backtracking recursion to solve it. You don't just go Google an answer, right? So like if we do this for lab, we just agreed to actually do it ourselves because anyone can go copy paste, right? That's no fun. But it's a good practice here. It's definitely a good practice. Okay. All right. So let's flip over to project one. That sound good? Talk about that one. All right. I think I gave a little bit of a buffer for anyone who was having issues. I don't think anyone else texted me this morning saying they had trouble. Yeah, I think we're clear. So let me start the new project for project one. Project one. Oh, do I already have something called project one? Oh, I do. All right, let me open project one and see what it is. Documents. Oh, good. It's the wrong documents folder. No, I don't want my OneDrive folder. I want the real one. There we go. The OneDrive is nice. Like, I don't hate it at all. It's just, what is this? What is Project One? It's not even a solution file there. I don't know what I did there. Documents, list real documents. There's not any code here. All right, I must have had something named Project One and then tried to get rid of it, but try that one more time. I'm sorry about that. It wasn't actually there. Project One. All right, so we had to do a couple things for Project One, right? We had a character class. We had some functions. We had a subclass of character. We had weapons. We had a subclass of weapon. Right? This whole idea, we wanted to practice using inheritance, practice using pointers, and getting runtime polymorphic behavior. That's the real magic here, right? If it looks like a weapon, but it's a special kind, I don't have to know what special kind it is. I just get the special behavior because of magic. And I'm sorry, magic's not the right word here, but it feels like magic sometimes. So like C++ says, oh, what do you really do? Which is super cool. So this is that idea of polymorphism. Right? We can treat objects of a parent type and get the correct overridden behavior from those virtual functions. It's fantastic. So a lot of questions from you folks around what do I need in my main function? Nothing. I don't have to have anything in main. I didn't ask for anything in main. The only stuff I asked for was the classes. That being said, if you didn't try it and make sure it worked, then how do you know you did a good job, right? So most people probably just write a main method. I like unit tests myself. And the value of unit tests is not so good here in class because you do the project and then you throw it away. Let's be honest, you're not going to keep this and be like, hey, I'm going to come back to this and play more with it and modify it and turn this into some really cool thing. We're just not. So having the unit test there doesn't really give you a whole lot. But in industry, when you write a piece of software, someone probably paid you to write that. So it's probably important to somebody. And most of the time, you don't get paid to write software and throw it away. Because, I mean, if you find a place that does that, let me know. Because I like writing silly software and then throwing it away. But so having the unit test there means I can test it on demand anytime I want and make the computer do the checking, right? And then later, because that piece of software was so good and so important to the business, they said, hey, we want to change it. We want to have it do more things, or we've got different requirements, or whatever happens here, because change happens in the world. As you go change something, you can still run the unit tests, and if they stop passing, you know you broke something important. You changed something that the rest of the program depended on, and we know we have to go fix it. So there's this idea here as we're writing software that bugs can get introduced. We call them regression bugs. We introduce bugs into things as we're trying to evolve the software. And something that used to work now is broken. We've regressed. We don't do the right thing anymore. Those ones are no fun because generally people are nice and they kind of understand, hey, this new thing that was supposed to do this mostly does this, but it's got an issue. And people are generally understanding and nice about that. But when something that used to work stops working, they get real pissed off at you. Like, hey, this broke. It's been working great for 2 years. Why did you break it? Right? And then they're not so happy with you. So avoiding those is super helpful, and having unit tests is part of that. Right? It's a good practice. So again, I'm just going to put things in header files because it makes it easy to test for me. I apologize, it's a bad habit. I'm showing you a bad habit, and we're going to acknowledge it's a bad habit because it makes our life easy. I will show you the right way to get things set up for testing later. It's just a pain in the butt. It's like 15 different clicks you have to do. And I tried it one time because I felt really bad about doing the bad thing. And then I got 30 questions on how do I set up my unit tests. It's like, I showed you, here's the 15 steps. And they're like, I forgot. Like, yeah, that's fair. It's okay. There's a lot of steps. Anyway, so we'll make our classes here. I'm still, I started with Java, and in Java you get one file per class, and I still like doing one file per class. I just like it. You don't have to. You can put as many classes as you want in a header file, right? Nothing wrong with that. I just like one per file. So I'm going to do one per file. So we'll start with character, right? So we have our class for character. We've got our private section, we've got our public section. Right, so we're going to use our namespace, because we're going to be using strings. String, yeah.
If we're making a subclass, wouldn't it be protected or private?
It could be. So if you want your subclass to have access to your attributes, you use protected. If they don't need access to it, they don't have to be protected. So it just depends on what you want to allow. Like, so for character and the magic character subclass, none of this needs any of the other attributes, right? Like, I do new things. That's basically all it is. I'm changing what attack does with my new attributes. I don't need access to any of them. So if you want to allow it, great. Protected's fine. If you don't want to allow it, leave them private. So we're going to have a couple attributes here for character, right? Name, max hit points, current hit points, dexterity, X location, Y location, and weapon. Well, if I need a weapon, I'm going to go add a header file here, so this at least will compile here. So we'll add a weapon, call this class weapon. There, now I have a class for weapon, so I can include that later. Okay, so we're going to have a string for name. We're going to have an int for max hit points, an int for current hit points. We'll have an int for X location, and an int for Y location. And then we were going to have a weapon pointer, right? Oh yeah, dexterity. Thank you for dexterity. Okay, and a weapon pointer for the weapon. Got a bunch of attributes. Cool. We should have get values, right? Get functions for all of our attributes. And the constructor accepts values for all the attributes. And so this is the easy way to set them in. Some of these things don't generally change. I know some people do change their name. We can say generally you don't, like your character in a game doesn't usually change their name, even though people in real life can change names, that sort of thing. Your attributes probably don't change. Right? Depending on your game, maybe they do. X and Y can definitely change, right? That's the set functions for X, Y, and weapon. But we're not going to change your max hit points. We're not going to change your current hit points directly, right? So there's no set function for these because we don't want to give you direct access for changing them, right? So we need a bunch of gets. All right, so we have, really wish that thing would just work, but that's okay. Get name, returns name. This is a little large here, but that's okay. I can just copy these down here. So we have an int for get max hit points, returns max hit points. We have an int for get current hit points, returns a current hit points. Oh my goodness, parentheses, that's what I'm missing here, parentheses. There we go. Int for get X location, parentheses, return the X location, and int for get Y location, returns the Y location. This looks really ugly. I'll fix it in just a second. Don't worry. Don't worry. And for get dexterity, returns the dexterity, and a weapon pointer for weapon, right? We'll get weapon here. Returns the weapon pointer. Sure. Nope. There. That was the semicolon, right? Nope. Nope. Inside curly braces. Trying to do this too quick. Sorry. All right. That one's a semicolon. All right. So it's not tabbed in pretty, right? Just go to which one? Which one is this? Edit. It's an edit. Advanced. And you want your format code. Where is it here? Where's our format? Format document. Yep, at the top. Format document. So Control E and then D if you like keyboard shortcuts. I can never remember all the different shortcuts here. And it will do all the alignment for you here and make it look a little prettier, which is really nice. So use the tool, right? Don't do more work than you need to. Be a good lazy programmer. So you get a bunch of gets. I didn't format all of them. E, D, there we go. All right, so these are gets here. We're going to need sets for X, Y, and weapon. Sure. So a void for set weapon takes a weapon pointer, Auto weapon, my this weapon then equals the weapon you give me. Great. Right. Accept a weapon pointer, set my weapon pointer equal to your weapon pointer here, which means the value assigned to my weapon pointer matches the value assigned to your weapon pointer. Right. Now we have 2 pointers pointed to the same location in memory. Right. We didn't make a copy here. It's probably okay. And again, that might matter later on if we so care. If someone like gives us a weapon and then goes and changes it later, it could do some weird stuff. Maybe. So, but the goal of this one was not all the copy constructors and all that good stuff here. We just wanted to get some polymorphic behavior. So we'll just assume good stuff will happen later. All right, and then a void for set x location, takes an int for x location. Like this x location equals the x location variable, our argument here, and then one for set y, I'll just copy paste. Set y location, y location, y location. So sometimes copy pasting is dangerous because if you don't change the right thing here, you did a bad thing, but I think we're okay. All right, and then we need a constructor that accepts all the values for the attributes. Sure. Some people like constructors at the top. I'm kind of fond of that as well, so I usually put them at the top. So this is the character constructor. It needs a string for name. It needs an int for max hit points. If you wanted, you could take an int for current hit points, or we could just default current to max. Whatever makes sense for your character. It's less typing for me, so I'll probably do that. X location, an int for y location, an int for dexterity, and now you could pass a weapon pointer here, or we could default this one, right? Maybe this is nice to have it just default to a null pointer. Whatever makes sense for you, right? Because we wanted to deal with not having a weapon. So I could pass you a null pointer here to create a character without a weapon. Sure, or I can make it easy on you and say you don't have to go do that and make a null weapon just to give me a null weapon, right? Either way is okay. I'm not particular about it here. And then we set all of these. So this name, the name, and then this max hit points, the max hit points. This current hit points is, we can just set current to max hit points, right? I think that works out fine. Sure. And then I might as well set x location, given the x location. I've got a function for it, so I might as well use it. Just why not? Y location. It's slightly less typing for me, I think. And then set weapon, given the weapon. Right? Oh, dexterity. We need dexterity. This dexterity. Dexterity. Okay, so we've set all of our values. Right? We got sets, we got gets. We're going to add a virtual function for attack, which accepts another character reference. If we have no hit points, nothing happens. Okay? If we don't have a weapon, right, using null pointer for the weapon, our range is square root of 2. If they hit, we do 1 damage. Right? If we hit, this is a roll the 20-sided die thing, figure out if it's more than their dexterity. Awesome. Okay, so let's make an attack function. So this attack doesn't really didn't specify returning anything here. I'm going to return a string just so I know what happened. You didn't have to, but I think that might make this nice here. We have this as an attack method that takes a character target. Right? If you give me the target here, I can go attack them. Okay, so first we needed to figure out if we have a weapon or not, if they're within range. Sure, right? We can do that. So we can say, hey, if my weapon is equal to a null pointer, then my range is going to be 2. Yeah.
And the function is virtual.
Yeah, virtual. Thank you. Virtual. Virtual. Yeah, because we're going to need to change this with our magic user. Thank you. Yep. So if the weapon is null, our range was square root of 2. So now we need to go find the distance here. Now we could just put those in here, right? Like in this if expression. Otherwise, you got an if inside of an if. Might as well use your logic. So I'm going to just add a private helper function here because I think this is probably easy enough here. So I'm going to say, how about a Boolean function is within range, given a character target, and then given probably a double here for range, right? What is my range? Just to make this easy here. So if we're within range, right? So we need to figure out the distance to the target, right? So the distance to the target as a double, this is distance to target, is going to be my x location minus the target's get x location, right? Take that and then square it, right? Do a squared plus b squared, figure out c squared. Okay, so you can do this. This is going to get a little long here. I guess times the same thing, sure. Oh man, yeah, okay. Times that, all of that, right? Plus, same with the y's, square the y minus y, y location, get y location, get y location, y location, right? Add the two squares together and take the square root of that. Math dots, capital M. No, it's just square root. It's just built in, right? Square root. Square root of all of that is my distance to the target, right? A squared plus b squared equals c squared. So take the square root of that. Yeah. The pow function. Okay. That's a little cleaner, right? Is that math.pow or is it just built-in pow? Nice. That is less typing. I like that. You can do that. Pow 2. Fantastic. Save me some typing. I'm a fan of that. Too many parentheses? That's that one. So I need one more here, then, right? One more. No? Is that too many? That's that one. Okay, now I need to end the square root parenthesis. Had too many. Or not enough. I can never remember. Seems like a lot. Okay. Right, so square root of a squared plus b squared is the distance here, and then we can return my range is greater than or equal to the distance to target. Distance to the target. Right? You could just do this calculation as well, and you don't have to save it, but you know, I'd like saving things so that when in debug mode, I can see what it calculates to. Because I've screwed this up before, doing a squared plus b squared to c squared, and it's the weirdest thing. Like, it's really easy to typo, so sure. Okay, so we can say, hey, if our weapon is null pointer, right, and is within range, the target, and our range then is square root of 2, right? Then what do we do? Okay, well now we need to roll the 20-sided die, see if we hit them. Okay, now if I'm going to do this more than once, right, probably want another helper function, right? So how about another helper function? A Boolean roll to hit. Sure. Is that okay? Okay. Roll to hit given a character target. So we need a random number from 1 to 20. So roll. I guess this is a d20 roll, right? A 20-sided die roll is going to be math.random. So that one I have to import, right? Just rand? Oh my goodness, rand. There's a lot of languages in my head, and none of them do the same thing. I'm sorry. Yeah, so rand, and then we want mod 20 will give me 0 to 19, plus 1 will give me 1 to 20. Okay, and then we're going to return my d20 roll is greater than, did we say greater than or equal to? I don't remember. Greater than the dexterity. Okay, greater than target.get dexterity. Right? Again, a lot of people, I think I complained about this last time, say, hey, if something here, return true, else return false. Did I complain about this already? Right? If you're saying if something's true, return true, just return the thing, right? Unless you're getting paid per line of code, right? So you just return that check here. Right? We don't need to say if it's true, give me true. If it's false, give me false. We can just give you the true or false value, right? Okay. So we could just add that in here too, right? In my right, if it's a null pointer and is within range, right? And roll to hit the target. If all of those things are true, awesome. make it take some damage. Now, we needed a way to function for take damage. Right, so we can damage the target, but it keeps it within range. Right, we don't want them to go below 0. Negative hit points isn't a thing in our game, and greater than max is not a thing either. Right, so we'll make a public function here then for take damage. So this is probably just a void function. It didn't say it had to return anything here. So take damage, given an int for damage. We're going to take our current hit points minus the damage here, and then if my current hit points is less than 0, set current hit points to 0. Why did that not line up right? Why did it put the if there? That's super weird. Okay, or if my current hit points is greater than the max hit points, take our current hit points set to the max hit points. Right? If we went below 0, just pretend it didn't happen. Stop at 0. Went over the max, pretend it didn't happen. Stop at max. Right? Okay. So if we hit, we can take target dot take damage of 1. Right? They take 1 point of damage. What did? Yeah. I think I missed a parenthesis. Is that it? There it goes. All right, missed a parenthesis. If we hit, and then we can return a you hit the target and they took 1 damage, or anything we wanted to have in here really. Is fine. We can have nice, pretty strings. We can figure it out later. Let the rest of the program figure it out. That's all fine. If this isn't true, then, right? Well, what else? Right? Well, else if weapon is not null, right? Weapon does not equal a null pointer and is within range. Now, weapon needs a private double for range, right? And then a public double get range, returns range, right? So we can get the range of the weapon here. You got a really long stick, or using like some sort of crossbow or bow and arrow, or any sort of ranged weapon, sure. So for not null pointer, then we're going to check is the target within range of what? My weapon.get range, right? Get the range of the weapon. That's the range we'll use to see if they're within range, right? And we roll to hit the target. If all of that's true, then the target, let's see, weapon needs a get damage as well, right? A virtual int get damage. So we don't have a damage here yet. So we needed a int for max damage in weapon. So it's going to be a random number 1 to damage, right? So rand max damage plus 1, right? So give me a number from 1 to max damage. Yeah, cool. So how much damage you do? Target dot take damage given my weapon dot get damage. Am I not having the right parentheses? Nope. This one there. That one. Okay. Now it's a little happier. Well, now we don't know how much damage they took, right? So we probably need to store that damage somewhere, right? If we're going to output it. Because it's a random value, so we can't just call the function again. It'll give me a different value, right? Shoot, that's a string. Was it int to string or something? Is that int to string? Or is it just toString? toString. toString. Sorry, we're not counting anything. I think we can append. Okay. Take the damage to string. In return, we took that much damage. If none of that was true, we're return you missed. Right? Whether or not we had a weapon or not, right? If they're not within range, we missed. Like You can swing all you want, but they're not within range. You could have different messages if they're not within range. Anyway, like I didn't specify what you needed here. I didn't even have to return anything. I want to see what it does because I'm curious now, right? That makes sense? Okay, cool. So that is our attack function. Oh, we didn't check to see if we have no hit points, right? So I guess all of this thing could be another check, right? If current hit points does not equal 0, then we do all of this. Sure. Else we'll return can't attack when you have 0 hit points. Sure. All right, now we got that one in. Nothing happens. We don't have the weapon, we did that. If we do have the weapon, we did that. We roll the damage, they take damage. Right? We have the take damage function. I think we're good then for character. Is that all the things for character? Hit everything? Cool. Let's finish up weapon here then, right? So name, damage, and range, right, for weapon. So a string for name, string, cool. So get damage, get range, get name, return name. That didn't format right. That's weird. Usually it'll like fix those curly braces too, but that's fine. All right. Do we want a constructor for this one? Probably, right? The defaults are garbage. So always want a constructor. Or not, you need to take all the arguments. It's up to you here. I think it's probably easier to take them all. So we just write a weapon constructor, takes a string for name, takes a int for max damage, and it takes a double for range. This name is the name. This max damage is the max damage. And this range is the range. Cool. So now there's no way to change those, right? If you don't have set functions, you can't change them. Well, that's okay. It's up to you. If you wanted to be able to change it, go for it. It's up to you. All right, so now weapon's done. Do you want to do the healing stick or do you want to do the magic user first? The healing stick? All right, so let's do a healing stick. So let's make another class here for healing stick. Class healing stick. We got to import our weapon, include weapon, colon, public weapon. Okay. We don't really even have any attributes, right? For healing stick. All it did was change get damage to return a negative value. Sure. So let's add in our get damage, right? That was an int for get damage. So a couple different options, and probably the easiest one here is we're just going to return my weapon get damage times -1. Now I have a negative number, right? I do need, though, a constructor, right? If my parent class has a constructor, I need to call it, right? Otherwise, I can't really make a healing stick. If I don't call the weapon constructor, it never gets created. So we're missing that. So we do need a constructor. So we need healing stick, needs a string for name, and then let me just copy those. I'll have to type it all. Right, and we just hand that over to weapon. And say, here's your name, here's the max damage, come on, and the range. Right, and then our constructor here then is just empty. I don't usually leave notes. This is a habit I got into. Like, yes, I know it's empty. Not, I'm an idiot and forgot to include it because that's happened too. So that's all. It's just a helpful note. All right, so we got a healing stick. We got a character. Should we add a magic character? Now this one, these are private, but we probably still want to use them, right? The rolling to hit, still the same thing. The is within range is still the same thing. So maybe these would be nice to put into a protected location, right? Make these protected so that my subclass has access to those functions. They don't need to be public, right? No one else outside of character cares what a roll to hit is, right? But I don't want to have to reinvent the wheel. I don't want to have to do it more than once. So I can have this protected level so that my subclass will have access to it, because it's a nice little helper function. This is the magic character. We're going to include character. Okay, and then we'll have a magic character, which is a public character, right? We're going to RA type of one of these here. Oh, class, sorry. Magic character. Charter character. There we go. We need a private section. We need a public section. Why is it unhappy? Expected a semicolon? Really?
Oh yeah.
Did it do that automatically before? It must have done that automatically on the other ones. That's fun. So magic characters then, what makes them special is they have an attribute for intelligence. Cool, so we have an int for intelligence. Okay, easy. We're going to override the attack function, have a different range, still roll the 20-sided die, take some different damage, but we need to call that constructor, right? And we need a way to set intelligence. So I like taking it through the constructor. So public magic character needs all the things character did for its constructor. Now, the problem with this one is weapon is always null for this one. We don't care about this. Maybe you can change it later, but I don't want a null pointer default here if I have another argument, right? These default arguments have to be at the end here. So I can't just say, hey, also give me an int for intelligence. You're going to really confuse C++, right? So defaults have to go at the end. So it's probably easiest just to skip that, right? Because we don't really care about the weapons at all, right? Then we can hand all of that to character, given the name, max hit points, the X location, the Y location, dexterity, and then I can just give it a null pointer, right, for the weapon. Or I can leave it null. Right? If I leave it null, it's getting a null pointer already with that default, which is nice. So when I call my base class constructor, it has a default for weapon being null. It's easy. I don't need to have one passed in here. Why? Added the republic again. Okay. So then I can set my intelligence to the intelligence you give me. Intelligence. I can't spell the word intelligence. That's a bad sign, right? There we go. Copy paste. Cool. Then we're going to override attack. Right. So this would be a string for attack given a character target. Okay. So our range is 10. So we don't have to care about weapon, whether or not it's a null pointer or not. We just check for range and then see if we hit. So we can say is within range. What do we call it? Within range. Is within range. There we go. Given the target, and 10 was our default range. Right. If we're within range, and we roll to hit target. If that's true, we'll go and hit them. We'll do some damage. That's my target. Take damage given my intelligence divided by 3. Right. Rounded down, so floor division rounds down for us, nice and easy. Integer division. Okay, and then we can return a you hit the target and it took, I guess just do the same arithmetic again, right? To string, append that in here, damage. Otherwise, we missed. You missed. All right, formatting was close enough, I guess. Is that it for magic character? Overrode attack. If they're within range, they do some damage. That seemed to work. Should we try it? You want to do a source file or you want to do unit tests? I could do either. All right, let's do some unit tests then. That's more fun. Let's go add a new project. We'll add our native unit test project, our tests. All right, so we need to include up a level, back to project one, back to, let's just do character, right? And if we're doing character, we also need a weapon if we're testing weapon, right? Project one, character, oh, not character, do weapon, and then we'll need the healing stick, and might as well do the magic character as well, right? We'll just include them all. Magic character and a healing stick. All right, so we've included all of them. So let's test, what do we want to test first? Like the constructors are kind of boring, but we could do that. I was going to skip that if that's okay with you, because those I'm assuming are straightforward. If that's a bad assumption, let me know. Let's test attack, or character attack hits. Why not? Okay, so if the character is going to hit, these are random values we're using to figure out whether or not we're going to hit. But if we give the target a dexterity of 0, is this ever not going to be true? Right, so by using different values for dexterity, we can force it to hit or miss, is how we can fudge that, and still use random numbers, right? Okay, cool. So we can try that. So we'll make a character for the attacker. Is going to be attacker, right? We don't really care about the name. Hit points don't really matter for the attacker. The X location 0, 0, sure. Dexterity for the attacker doesn't matter. And then we want no weapon, right? So this is character attack hits no weapon. How about that? No weapon. Then we need a character that's the target. Target probably needs some hit points, right? Give them 1 hit point because we want to see if their hit points change, right? And then let's put them at 1, 1. And then their dexterity, if the dexterity is 0, we always hit, right? This makes sense. Like, so we're setting them up 1 square away. We're going to hit them. They don't have a weapon. It should deal 1 damage. So we're setting up the things that we need here, right? Then what else do we're going to have an expected hit points. It should be 0, right? If you started with 1 hit point and you got hit, you should go back down to 0. Let's actually test the code, right? This is our arrange, and this is our act, and this is our assert. So we'll take the attacker, we'll call the attack method on the target, right? And then we'll have an int for actual hit points. It's going to be my target.get hit points, or get current hit points, right? And then we can assert that they're the same. Assert capital A are equal my expected hit points and my actual hit points. Did they match? Right? Should hit, should do 1 damage. Let's open up our test menu. Come on. Test Explorer. There we go. Give it a run. You guys don't look confident in me. It's okay. Oh, it failed. Expected 0. Actual was 1. Well, something didn't change right. Let's put a breakpoint in. See what happens. So that's the other fun thing. You can debug your. I guess you can debug your source code too. But let's go back to Test Explorer, and I want to debug the test. All right. So we've got a attacker and we've got a target. So let's step into the function here. Now we're in attack. Right. So the this then is the attacker, right, and the target is the target. Right. So let's see. So far, our hit points is 0. We missed because we're dead. I didn't give any hit points to the attacker. That was a mistake. Dead attackers can't attack. All right, so let's fix that. So let's give them 1 hit point. right? I think that was hit points. Let's try it again. Uh-oh. All right, let's go again. Debug it again. What's next? All right, let's step into our attack function. All right, hit points is not 0. Good. All right, is weapon null pointer? Yes, they are within range. Yes. All right, they're going to take damage. Now, target, current hit points is 0. Right? Cool. We're going to return a value. We come back here. Uh-oh. Target. Target didn't change.
I think wasn't someone on Discord saying the same thing where they had to put the reference.
Yeah.
Yeah.
Yeah, remember, we get these funny copies if we're not careful here. So explicitly, I want the, is that to attack the, no? What am I doing wrong here? Not a pointer. Oh, goodness. Oh, man, I'm going to be confused real fast here. So target, it's fine. I just need to give them the reference to target, right? Is it that side? No. It's the front side, isn't it? Is that the front? Instructor, this to convert character to character. Character pointer. To character. You could specify it. A character reference. Or you're saying when we make in the test itself?
Yeah, I don't know. Because I think I had actually used character pointer.
Okay. We could. I'm so upset here. That's obnoxious. And then just give it, well, then you'd give it the dereferenced value, right? Okay. Sure. So if we make this on a pointer, new character, and then we give it dereferenced target, target get. Let's try that. We'll try it. This is why you guys didn't believe in me. It's okay. It's well earned. Did it still fail?
I think I had done that, and I did the reference symbol in the attack option.
Maybe the reference.
Is the character function.
Declare this one as a reference?
Yeah, I think that was fine.
Let's see. It passes. Look at that. That's why this stuff is annoying. The default copies for things is always frustrating. But this is why we test. Right? Tests are good. All right. Awesome. So we have a passing test. So our character doesn't attack with 0 hit points. Right? That was the first one we did by mistake. So if my attacker has no hit points, nothing happens. Right? Again, all sorts of the tests, like if we wrote some code, we probably want to make sure that they work. So if we've got a block here, make sure that the other block runs. Right? This idea of code coverage, am I testing all these things here? Right? Then we can test with a weapon. Right? That one should be a pretty easy one. Let's do a regular attack with a weapon. Now, weapons, right, are random values from 1 to max damage. So we're not going to have a specific number to check, right? But it should go down, right? Their hit points should still go down. Is that fair enough to check? Don't really have a super handy trick there. This is hits with weapon. So if we give them a weapon, right? Let's make a weapon equals a new weapon. We don't really care what the name is. The damage here, let's just say is 10, right? The range, we'll just give it a good range here, right? All right. So pointer. And then we can give them the weapon when they're the attacker. So we want to make sure they have a lot of hit points, right? Let's like start them maybe at 20, right? and it should go down some number here, right? So I don't really know expected hit points. It's just going to be less, right? Some random number 1 to 10. It'll be less here. So we can go attack, get their actual hit points, and then we can assert is true, and we can say my actual hit points. I guess we'd probably use another integer here. Would be nice. There we go. Import starting hit points. 20. There. Now we have a nice name for it at least. And we can say my actual hit points is less than the starting hit points. Right? Should have gone down. We don't know what it went down by, but that's okay. Right? As long as it goes down, that should be true. Let's run our tests. Cool. Right? And then this doesn't attack. How about is out of range? Right? Doesn't hit when out, not in range or something like that. Sure. So if we just put them at like 2-2, then they shouldn't be hit. Right? They should stay at 1 hit point because we can't hit them. That's with or without a weapon. We could test it with a weapon too if we wanted later, if we cared, because we are checking within range, I guess, both times. Cool. That one seems to work. All right. I'm sorry. Oh. Should we try like see if we can heal somebody? Test out the healing stick. Healing stick heals. Sure. So we'll give them, instead of a weapon, we'll give them a healing stick. Name, max, range, inaccessible. What did I do here? I didn't put that in the public section. There we go. Those are public functions of healing stick. There we go. So we get a healing stick. We can save it in a weapon pointer, right? Because it is a type of weapon. I still pass it to the character. Now the target we need to have take some damage, right? So we'll do target take damage. Let's do, I don't know, take all 20 damage. Why not? And we'll go attack them with the healing stick. And now their actual should be greater than 0, right? So actually, I can do that. So give them starting hit points, take away all the starting hit points, hit them with the healing stick, and make sure now they're greater than 0. Right? Let's give that one a try. Hey, the healing stick healed. Okay. The magic user, right? Magic attacker, magic character. Right. This is magic character. Character hits. Sure, just hits. Why not? So this will be my magic character. Now we don't need a weapon, right? We need some sort of intelligence, right? So if the intelligence is, I don't know, say 10, right? That should do 3 damage, rounded down. We'll have an expected hit points. Expected hit points. So this one should do, right? If they start with 10 hit points, they should go down to 7. Should do 3 damage when we attack. So that's R equal the expected hit points and the actual hit points. Right? Okay, let's try that one. Uh-oh. Expected 7, actual was 10. What did we do wrong? Oh, did we never change the attack here, did we? To be a character target, a reference? Was that it? There we go. Take the reference instead of taking a copy. It's so annoying. How do you feel? We get it all done? Do we have a character class, a magic character subclass, weapon class, and healing stick subclass? They do as advertised? Cool. Okay, awesome. And we get the polymorphic behavior. Right? We didn't have to specify, we didn't have to change the attack, which is cool. Right? If you have a weapon, get the damage. That's kind of the like behind the scenes magic, the whole reason for practicing this. So if we set things up, we can go and change them later or add new features later. You guys play any video games that like constantly update and add new things? My kids play Fortnite all the time, right? They like that. Their little cousin really likes it, although he doesn't like being shot. So the rules are not allowed to shoot him, but he can shoot them, and they're pretty good sports about it, which is really sweet. Yeah, seem okay? All right, we've got just 3 or 4 minutes left here. We talked about recursion. We looked at the backtracking solution here, but the general form when we did backtracking, right, was find the next step, solve. If you're stuck, undo the step you did, and then it goes back to trying that next step, right? Because that works because it all just gets thrown in the stack here. Actually, I think I can. Let me open up that project. I want to show you. Let me just close it, reopen it. It's probably faster. There we go. Eventually, we have all these calls in the call stack, which is fun. So let me put a breakpoint in here. I can do those conditional breakpoints, so like pause at a certain point. Those are so nice. Here, so let's do a breakpoint in solve for, let's do, say, conditions want value equals 9. Right? Let's try that. So when we get to a 9, we'll take a break and see how far we got. There we go. So, oh, it's not showing me. It doesn't show me the call stack, does it? Did it crash? What did it do? There it goes. Broke it, apparently. I never got to 9? I must have done something wrong here. That's fine. Let me just put the breakpoint here. I want to show you in the call stack, right? You can kind of see, I think we looked at this before. If we just continue and continue and continue and continue, see they go added to the stack and they get taken off the stack, right? So as we try numbers, we're seeing, hey, at this point here, right, value is currently 8. The open indexes are 8 and 0. And the next time, okay, my value is 2, my open indexes are 1 and 1. So for each of these calls here, I can click back on them and you can see what the values are. Right? This idea, all of that has to be tracked in the stack there. And that's why you can overflow if you're not careful with your recursion, but we can see what the values are as we go. They just keep getting added to the call stack. Right? So if we had a completely empty Sudoku board, we could solve it and we'd have, what is that, 81 calls in the call stack. Right? First open position, the second open position, the third open position, but it should be able to solve Sudoku, right, given an empty board. You know, and any sort of combination here should be able to solve. So we're not going to get, I mean, 81 is a decent amount of function calls, but it's not a crazy amount, right? I forget how many it needed to overflow the stack, but it was a lot before we overflowed. So, all right. So that's what we're looking at. So as you watch it here, you kind of see these steps go. Okay. Oh, no worries. We're just finishing up. All right, so we'll call that good. So we'll meet up for lab today at 6, and we'll practice some recursion. We'll build a maze solver in lab. It should be a lot of fun. We didn't talk about the next project. That's what we ran out of time for. I'll talk about it in lab. Is that all right? Okay, cool. So we'll talk about the project in lab, practice the maze solver, and go from there. Thanks, folks.